In our next question, we see that Jermaine purchases 5 slushies and 7 freezies for $9.50, and Belinda purchases 6 slushies and 10 freezies for $13. We want to know what is the price of a slushie and what is the price of a freezie. Well, we want to know the price of a slushie and the price of a freezie, so we can let S be the price of a slushie and F be the price of a freezie. Now, 5 times the number of slushies plus 7 times the number of freezies is $9.50. And, or sorry, I should have said 5 times the price of a slushie plus 7 times the price of a freezie is $9.50. And secondly, 6 times the price of a slushie plus 10 times the price of a freezie is $13. Well, what we've got now are 2 equations, 2 unknowns. We have a system of equations. In our next question, it says Jolene can run 8 meters per second on pavement and 5 meters per second on grass. She ran for a total of 2,000 meters and it took her 5 minutes and 40 seconds. And we want to determine how far she traveled on each surface. Okay, so remember it's asking how far she traveled on each surface, so what we can do is let the distance traveled on pavement be one variable and the distance traveled on grass be another variable. Okay? But before we do that, note also that it also said it talks about time in here. So it talks about distance and it also talks about time. And so we have to recall a relationship between distance and time. We know that speed is distance over time. And since speed is distance over time, then we can also say that time is distance over speed, like we have here. Now I personally find this little diagram helpful. Speed is distance over time, meaning time is distance over speed. So what we're going to do is we're going to make one equation based on distance. So we're going to let P be the distance Jolene ran on pavement and P and G be the distance Jolene ran on grass. Our first equation is going to be based on distance. The distance on pavement plus the distance on grass equals 2,000. The second one's a little tougher. For the second one, we know how much the total time was. So we're going to say the total time spent on pavement plus the total time spent on grass was 340 seconds. We'll get to the 340 in a minute. But first of all, we have to remember that distance over speed is time. So the distance traveled on pavement is P, the speed traveled on pavement is 8, and since time is distance over speed, the time spent on the pavement is P over 8. Next, we see that the time spent on grass should be G over 5 because the distance on grass is G, the speed on grass is 5, and so the time, being the distance over the speed, means the time on the grass was G over 5. Okay? Now, the total time spent was 340 seconds. And you might say, well, it was 5 minutes and 40 seconds, but remember that 5 minutes and 40 seconds is like saying 300 seconds and 40 seconds, because every minute has 60 seconds, so 5 minutes is 5 times 60, 300 seconds, plus the other 40 seconds gives us a total of 340 seconds. So our first one, based solely on distance, is distance on pavement plus distance on grass is 2,000. The second one, based on time, is the time on the pavement, in other words, distance on pavement over speed on pavement, plus the time on the grass, in other words, distance on grass over speed on the grass, equals the total time, which is 340, because time is distance over speed. Yeah, that's a tough one. Okay, next one here we have what's called a mixture question. We see that Smarties cost $15 per kilogram and M&Ms cost $12 per kilogram, and we've got 2 large boxes of these items mixed together by accident. We want to know how much of each type of candy was in the resulting mixture if we know the resulting mixture is 90 kilograms and it costs $1,200. Alright, there's a lot to digest there. So what we're going to do, first of all, is we're going to let S be the number of kilograms of Smarties, and we're going to let M be the number of kilograms of M&Ms. Okay, that part's kind of easy. But here's where it gets kind of complicated. Or I shouldn't say it's easy because it's new for you, but that part's relatively straightforward. But where it gets a little more complicated is when we get into the diagram. It talks about the cost per kilogram. Well, we know that the cost per kilogram is equal to the total cost divided by the number of kilograms. Okay? Well, making this little pyramid and having the visual of it for me is useful. And when I see that the cost per kilogram is the cost over the number of kilograms, that helps me to know that the total cost is the cost per kilogram times the number of kilograms. Well, the first thing it tells me is that the number of kilograms of Smarties plus the number of kilograms of M&Ms is 90. It's a total of 90 kilograms. Okay, so the number of kilograms of Smarties plus the number of kilograms of M&Ms is 90 because it told me in the question that the resulting mixture was 90 kilograms. So I make an equation based on mass. The next equation is going to be based on cost. What is the total cost of all the Smarties? Well, it's $15 per kilogram times the number of kilograms. S is the number of kilograms, and $15 per kilogram is the cost of the Smarties. So 15S is the total cost of the Smarties. And 12M is the total cost of the M&Ms because M is the number of kilograms of M&Ms. $12 per kilogram is the price per kilogram of the M&Ms, and the cost in total is the cost per kilogram times the number of kilograms. So we have two different equations, two unknowns. We have a system of equations. In our next question, we see that Miriam is selling school spirit decals. She's going to pay a total of $50 in advertising costs, and each decal